All right, continuing with our notes on Chapter 6, Floods. We're picking up with Section 3 right here, and we've been talking about how streams work, how streams and rivers work, and how floods actually, where floods can take place. Now we're going to pick up with actual places that are at risk for flooding. And so I think it would be obvious that any place that receives any kind of precipitation has the potential to flood. Now, precipitation can be rain, it can be snow. Oftentimes, when snow melts, it contributes to flooding. Even in some small way, fog, which is considered precipitation, could actually contribute in some small way to flooding. So all those are examples of precipitation that could cause flooding in a certain area. But of course, certain areas which get different amounts of precipitation are different risks for getting flooding. But in the United States alone, all right, floods were the #1 disaster in the last century. And it's easy to think of more catastrophic things like hurricanes or tornadoes, but it's really floods, as common as they are and as damaging as they can be. They were the #1 disaster in our country in the last 100 years. Billions of dollars of property damage can be caused. We're not just talking about buildings getting destroyed, but we're talking about land being changed, like farmable land being changed to not farmable. So if you consider all that stuff, you can add it to billions of dollars. Somewhere in the realm of 200 deaths was, I guess, around the worst in terms of people dying in flooding. But not so much, but even more so than the United States, developing countries, or you might say second or third world countries, have even greater losses due to flooding because there's not much monitoring. All right, people don't really know the causes of floods or the repercussions of them. They don't have warning systems that we have right here. Infrastructure, that is, ways to manage floods. All those they don't have, and so people in third world countries are much more likely to suffer losses as a result of floods. Take a look at this next slide here. This graph shows how the various different continents, Europe, Asia, the Americas, and Africa, by far Asia, that yellow right there, has probably the largest number of third world countries of all the continents, and they've got the most affected by floods. We're talking about number of floods, people killed, people affected or displaced, economic loss, much greater in Asia than in the Americas. All right, now it's probably hard for you to see in your notes right here, but in the United States, we have certain rivers that are much more likely to flood than others. You've got the Ohio and the Mississippi River right here mentioned. And you have, let's see, where's the Colorado? Man, this is really hard to see, isn't it? But we'll talk more about this. Here we go. It's Colorado down here in the bottom, right here. Okay, so on to section 6.4, the actual effects of flooding. Now, when we talk about effects, we talk about primary effects and secondary effects, and also how these are linked to different types of disasters. So, obviously, the foremost primary effect that can happen is that people lose their lives. Flooding involves water. Humans tend not to be able to breathe underwater, and so if you're pulled under, it can cause drowning. Not just because of not being able to breathe, but also being carried away by currents and stuff. I mean, that debris and all that stuff, it's not exactly like the most smooth flowing liquid, and so if you have a lot of jagged objects in there, they can result in loss of life as well. Damage, of course, to homes and businesses and other infrastructure is also a possibility. But not just that, but also you've got things like vegetation and soil being worn away because of erosion. So all those things, people dying, property being destroyed, and the environment being changed are all primary effects of floods. On the secondary side of things, the rivers themselves can be polluted as a result of the floods. I mean, the flood can be done, but you can still have a polluted river because of all the sediment that was washed downstream. Hunger and disease are a big issue. If you've got floods that flood a really broad area, all that water is contaminated, and it's very difficult to get fresh, clean drinking water or other resources. So hunger and disease are an issue, as well as homelessness too. So if buildings are destroyed, then people are going to be without their homes. So all those things, well, the first part was primary. The second set was secondary issues as a result of floods. So what affects how much damage is actually caused by floods? Well, if you're on a floodplain, it means you're on an area that is likely to be flooded. And so the more you use the land right there, the more likely you are to have to incur damage to your property or to your person. Also, how the flood waters themselves, how deep are they? How fast do they move? Obviously, the deeper the water, it affects a broader area. And the speed or velocity of the floodwaters can cause more carving out of the stream channel and cause more erosion. So those are big issues as well. How about the duration of the flooding? Does it happen and just kind of immediately subside, or does the flooding stick around for days or weeks? That plays a big part in how much of an effect the flood is going to have on you. Sometimes the season of the year the flood takes place. Remember, we talked about in the previous section how the ability or inability for water to sink into the soil determines if it's going to flood or not. Well, what if it's the dry season of the year and all the soil is hard and packed down and cracked? It's not going to be able to seep in, and so you might be more likely to have a flood during a dry season when rain does come than in a different season of the year. The season of the year can play a part in that as well. What kind of sediment is transported downstream? Is it very fine stuff? Is it very jagged blocks? I mean, all those things can contribute to how much the stream channel carves out. And finally, we have this is kind of a human element right here. How good of a forecasting do we have? How good of a warning system do we have? And how well can we evacuate people? All those contribute to how much the flood actually has an effect on you. We said in third world countries, there is somewhat lacking in these areas right here because, because they're lacking, floods can actually have a bigger impact in third world countries. What other natural hazards are linked to floods? Well, hurricanes can sometimes cause floods. I mean, we know the floods are partly a result of a lot of precipitation all at once, and hurricanes certainly bring that. What they can do is floods can even sometimes cause earthquakes to take place. I mean, floods put a lot of water on the ground and can actually set off minor and sometimes even major earthquakes simply because of all that weight, that extra weight on the Earth's crust. Landslides, of course, are an issue with earthquakes because as the ground gets saturated and soggy, it tends not to hold together very well and tends to slide down slope. We're going to talk more about that next chapter. But fires are an issue. If you watched the Nova special on the 1993 floods in the Midwest, there was a natural gas repository where you had all these tanks of natural gas that were very delicately, they were in a position such that it was very precarious whether or not they would actually explode or not. Thankfully, they didn't, at least not in St. Louis. But so fires can be an issue because of the way that the flood waters affect electric and gas mains. And also the coasts themselves can be eroded because of floods, because of the sediment on coasts being able to be washed away by floods. So all these things are linkages to other natural disasters that can also take place. So floods themselves, though, can they be good at all? And the answer is yes. That's what we mean by a natural service function. Sometimes we actually need floods. Part of the reason that the Mississippi Valley is so desirable to live in and farm in is because floods have deposited sediment there over years and years and years and make it a very great place to farm. And the problem is that floods sometimes wash that away from time to time. So I sometimes say that sometimes you got to pay the piper. If you get a benefit from nature, sometimes nature takes away that benefit as well. But especially if people try to build on that floodplain right there. So floods can provide fertile sediment. Aquatic ecosystems can benefit from floods because it brings in more water and can expand their habitat. And believe it or not, it actually can help keep land above sea level because floods bring sediment downstream, and they build up that sediment in places very much like New Orleans that that need that to keep the river and the ocean back. So the floods can actually have some nervous functions. So floodplains like the Mississippi River Valley right here. It's really built by floods, and if you were to look at the Mississippi River Valley, you would see there is a floodplain extends pretty far in each direction on either side of the river. That's been carved out by the Mississippi River flooding very regularly over hundreds and hundreds of years. Most of it is very fine material, silt and clay and organic matter. That's good because organic matter, it makes for good fertilizers. And so that's why the Mississippi River Valley is one of the most fertile places in the United States because you have the water and you have the nutrients required to grow crops. So it's a natural fertilizer for the soil on that floodplain right there. All right, what else does it do? Well, aquatic ecosystems. Floods enable stream channels to get kind of flushed out. Sometimes stream channels naturally get blockages in them, like logs and tree branches. Things fall in and make kind of naturally made dams. Well, to clear those dams, floods can flush those out, including boulders as well. The other thing that aquatic organisms benefit from in floods is that they get nutrients that are washed downstream. I mean, not only is it good for farming, but also the organisms that live in the water they benefit from nutrients that come downstream. So that floods are good in that way as well. People that live in environments where fishing is common, they benefit from floods because it kind of brings in a new influx of fish and other organisms they can try to catch. All right, and the fact that it brings down sediment actually builds up elevation. Like I mentioned before, New Orleans is a city that part of it is actually below sea level. It's built below sea level, but they have levees and seawalls that keep the ocean back. Well, the Mississippi River that comes down through New Orleans it constantly brings down sediment, and that sediment can be used to build up the elevation and keep parts of the city above sea level that they wouldn't normally have been have been above sea level. And sometimes even that sediment can help prevent damage from hurricanes as well. So we have actually taken floods and experimented with them in a kind of a man-made way to see if we can sort of harness nature a little bit. Obviously, you know that that we can use moving water. We can harness the power of moving water to create electricity, and that's what the Glen Canyon Dam does. The Glen Canyon Dam is on the Colorado River. It's one of several dams on the river. You probably have heard of the Hoover Dam. It's just upstream from the Hoover Dam, and the Glen Canyon Dam it backs up the water and creates a lake called Lake Powell. All right. Well, before the dam was there, before the Glen Canyon Dam, it was another canyon, not very far from the Grand Canyon, through which the Colorado River moved. All right. Well, since the water is backed up, we now have this lake. But beforehand, it was very different from the way that it is right now. The Glen Canyon Dam, it was May or June is where you had the most discharge, the most flow, because the snow had melted from the Rockies and was coming down from Colorado and was kind of reaching its maximum right in May or June right there as all the snow was melting. And so the rest of the year, the level of the Colorado River kind of receded because there wasn't much more water coming down from the Rockies over the course of the year. Flash floods were common because there wasn't much tree cover or things to prevent the movement of water. But whenever there was water, it would be a quick flash flood. But it was just kind of receding during the rest of the year. When it did have a lot of discharge, All right, it could transport sediment very, very rapidly because the water was moving really fast. All right, so all this moving sediment scoured the channel and just cut it deeper and deeper and deeper. And so it kind of created these bars and terraces along the channel, sort of like these, almost like these stair steps. If you look at the Grand Canyon, it looks kind of like a stair step down on the sides. Well, the same thing was true of the Glen Canyon, or sorry, of the Colorado River before the Glen Canyon Dam was put in place right there. But after the Glen Canyon Dam, now remember, what the dam does is it backs up water. It uses the power of the moving water to create electricity and also creates this giant lake behind the dam. We had the most frequent discharge increasing about 66%. Part of that is because you had this lake that is backed up, and so you have a constant amount of water that is flowing through the dam right there. But it also meant that the flood in the Colorado River was reduced about 66%. Because we have this dam and this giant lake behind it, all right, you could sort of use that lake as a buffer to kind of collect a little more water or let water out. And so you could actually control how much it flooded downstream in the Colorado River as a result of the Glen Canyon Dam right there. It also meant that the 10-year flood, that means the flood that's so big it's only likely to happen once every 10 years. That likelihood was reduced about 75% as well because the Glen Canyon served to kind of control the flow of water downstream. There's some drawbacks as well. It also meant that the rapids downstream were more dangerous because since the dam was letting water out at a constant level, at sort of like not really a trickle, but not as much as it had been, that meant that large objects were not able to be moved by the water as much. So you had more dangerous rapids because large objects in the water weren't moved. And you also had some sandbars disappearing because the water coming out of the dam was pretty clean because it didn't have much sediment in it because all the sediment had been dropped in the lake behind the dam right there. Some good things about it, since there was no floods, new plants were able to grow alongside of the river. And generally speaking, it just kind of restored the river to kind of a more natural state or to more of an equilibrium. So what they would do is from time to time they would do test floods where they would flood the river below the dam with a lot of water just to kind of see the effect that it would have. And so they experimented to sort of redistribute the sand supply because there was a lot of sand kind of backing up behind the dam, and they thought maybe releasing a lot of water would have let some of that sand move downstream. It had the result of forming a lot of new beaches along the lower part of the Colorado River and adding sand to a lot of the existing beaches right there. Some marshes and backwaters that allowed to rejuvenate because more water was being allowed downstream. And remember, this is a human-controlled experiment, and so it was allowing water to rush downstream, kind of help rejuvenate marshes and backwaters, that kind of thing. Even though the new deposits didn't last very long, it was considered a success. So we can use dams and rivers to sort of control how the river downstream looks, and so we can let more water out or let less water out, and that will determine kind of the health of the downstream river. So that's how we can kind of tinker with nature by doing controlled floods behind dams. So here's a Colorado River basin right here. Remember, the basin means that it's a whole area that if any water, any rain falls in that area, it's going to run into that river and then eventually out into the ocean, right, the Gulf of California right here. So the Glen Canyon Dam is at the base of what's called the upper basin of the Colorado River, and the Hoover Dam is right in the middle of the lower basin of the Colorado River. But this giant area shaded in blue is the whole basin, it's the whole watershed of the Colorado River, which eventually takes all this water and empties it down into the Gulf of California.